Hi, so it's time for part two of your test review. And this past unit, we have talked about accuracy versus precision and how a lot of times we use the same word. We use accuracy or precision kind of interchangeably, and there's not much difference, but in fact, there actually is. And so we want to talk about what they both mean and the difference. And so accuracy is how close you are or your measurements are to the true or accepted answer or accepted answer. And remember, if I'm writing this down, you should be writing it on a piece of paper so that you are studying and really doing what you need to do for your test tomorrow. And precision is how close each measurement is to each other. And so there really is a difference between these two. So if we look, for example, at a dartboard, we know that in a dartboard, the goal or the accepted answer is the bullseye in the center. And so if we want to look at something that is accurate, we might see 3 darts thrown in the bullseye. And so this would be an accurate measurement. Now, because those 3 points are also very close together, we could also say that they are precise. But what if we have 3 that are kind of like this? They're spread out. We would consider this not precise. They're not very close together. However, their average is going to end up being somewhere in the center, and so we would actually still call this accurate because it's not how close a single measurement is, but how close your average is. Okay, that's important. Your accuracy is about your average, and precision is about each individual measurement. Now, what if we look at something that is precise but not accurate? Okay, something that would be precise is if I throw all 3 darts over here. They're very close together. However, their average is nowhere near the bullseye. And if you are just really bad at darts, you're going to be not accurate and not precise. And that might look like this. Okay, all far apart, the averages, it's not really going to make sense. But we know that in science, we're not really working with dartboards. So you want to know, Ms. Nichols, what does this look like with data, with numbers, things of that nature? Well, let's take a look at this chart that I have so kindly created for you. So these students, student A, student B, student C, and student D, have been taking measurements, and we see that their measurements were in grams. So that tells us they were using a what? That is correct, a scale, and that these are all mass values. Okay, so they're using 4 different scales, and they want to know which ones are accurate, which one is precise. Now, they were all weighing the exact same object, and their object had a mass that was equal to 97.8 grams. Okay, so we need to look at whether or not something is accurate and precise, and we're going to label each student with their numbers. So because we already circled the G in student D, let's look at theirs first. Now, to determine accuracy, we need to look at first their average. So the averages for all of their trials are this very bottom row. And if we look at the average for student D, they have an average of 95.9 grams. And so because our true value is 97.8, we would say that this student is not accurate. And then for precision, we look at the individual trials, 93.2, 99.7, 94.8. They're spread all apart. They're not close together, So this person is also not precise. They are not going to be getting a good grade on their lab. Let's look at student C. Student C, 95.5 grams, 95.6 grams, 95.5 grams. Their work is very precise. Okay, all of their numbers are very close together. However, their average 95.5 grams is not close to our true value of 97.8, so they're still not accurate. This probably means that they were making a mistake and they were making the same mistake every time, which is better than making a lot of different mistakes inconsistently like student D. Student B, 99.0 grams, 96.5 grams, 97.8 grams. Their numbers are kind of all over the place, so this person would not be precise. However, if we look at their average was 97.8 grams, and because that matches our correct value, they are accurate. Okay, now I would label this person is just lucky. They're making all kinds of different mistakes, but luckily for them, their average came out to be accurate. This person, student C, they are making the same mistake, which is why they can be precise, but they're not accurate. And this person is just bad. They're making different mistakes at different times. And if we look at student A, 97.8, 97.9, 97.7 grams. All of those numbers are within 0.1 of each other, and so we would say that this person is precise, and their average matches ours, so it is accurate. And so we would say that this person here has good data. Okay, now along with accuracy and precision becomes the formula for percent error, which remember, percent error has to be memorized for your test. I am not giving it to you. So percent error's formula is equal to your experimental value minus your accepted value divided by accepted value times 100%. For example, if we were to take one of the data points from our graph, let's say we want to know how wrong. We know that student C was wrong, but we want to know how wrong. So we're going to take their average value here, which is going to be their experimental value, 95.5 grams. That is the number they got in their lab. And we are going to use 97.8 grams as their accepted value. So that would look like in our formula here, we'd say their experimental value of 95.5 grams minus 97.8 grams divided by 97.8 grams times 100%. Now, this can get tricky with significant figures, so we want to pay attention. 100% is a counting number we don't use in sig fig calculations. Okay. However, when we subtract, we use the lowest number of decimal places, and when we divide, we use the lowest number of significant figures. So when we're calculating this out, we're first going to do the calculation for the numerator. 95.5 minus 97.8, which gives us a negative 2.3 grams. Now, you're allowed to have a negative number here. The negative or positive doesn't really tell you that you have less, but the negative means that they were 2.3 grams under what they should have been. Negative just means lower than expected, and positive just means higher than expected. So it tells you in which direction you did something wrong. And then we're going to divide it by 97.8 grams. Now notice, because I have grams on top and bottom, they're going to cancel out, which is good because a percent error should not have any units. And then we're going to multiply it by 100%. And so negative 2.3 divided by 97.8 times 100 in our calculator is going to give us negative 2.35173824, which that's a lot of numbers. So we know that we need to use significant figures. 2.3 has 2 significant figures. 97.8 has 3 significant figures. So our answer should only have 2 because, again, we don't use 100% in our significant figure calculations. So 2 significant figures would be 2.3. The 5 would make our 3 round up, so our answer should be negative 2.4%. So overall, even though student C was not accurate, they were pretty close. They weren't that far off. So because they were using a scale, that might have meant they didn't transfer everything completely if it was a powder, or maybe that their scale is just uncalibrated and they need to recalibrate it. Or perhaps they didn't use the tare function when they were using their weighboat. So all of this to say, for your test, you need to know your percent error formula. You need to know the difference between accuracy and precision, and you need to be able to tell the difference. And remember, it is all about the average value for accuracy. So if on your test, I do not give you the average, which I'm not guaranteeing that I will, you need to be able to do the average yourself. So remember, we did that by adding these 3 together, and then because I have 3, we divided by 3. You should know how to take an average. If you don't, Google it. But that is something that you should have learned from all of your math classes. So this is part 2 of 3 for your test, and part 3 will be available soon.